pressure. So the first question is dimension of pressure. So it is m1 L minus 1 T minus 2. Next question is SI unit of pressure is. So SI unit is Pascal or Newton per meter square. And it can also be written as kg meter minus 1 second minus 2. So all of these are the same thing. These type of questions are asked many times in NEET, JEE Main and even JEE Advanced from the chapter Units, Dimensions and Measurement, where you are being asked to find the units in various possible cases. So all of these are same thing. Then is the concept 1 Pascal. This is equal to 1 Newton per meter square and is also equal to kg meter minus 1 second minus 2. So all of these are same things. Next is 1 atm. So this is equal to 1.0134 into 10 is to power 5 Pascal as per NCERT data. 1 bar is equal to 10 is to power 5 Pascal. 1 atm is equal to 760 torr. Now we have another question based on calculation of pressure at various points. So pressure at A here. So pressure at A here will be P naught plus rho GH, and if height is 0, pressure will be P naught. If we see the graphical variation of pressure with height, so it will be a straight line like this. Similarly, for variation of pressure with density, the graph will be like this, straight line also. Now for freely falling container, pressure will be equal to P naught. So pressure will be same at every point. Now if container is kept in elevator accelerating upward, so replace G by G effective will be, which will be G plus D in this case. Now in moving downward, we replace G by G minus A and can solve the question easily. Yes. Now there is a discussion on stress and strain. So we are being given a circular cross section of radius r. Force is applied as shown in the figure. So we need to find the longitudinal stress on the circle. So for finding longitudinal stress, we need to take component of force perpendicular to the plane or along this surface area vector. So this I denote as F perpendicular. So if I take the component of force, that comes out to be F sine beta, and area here is pi r square. Now this sine beta can also be written as cos alpha because alpha plus beta is 90. So in this way we can find longitudinal stress on the circle. In another question, we can find tangential stress by taking component of force parallel to the surface, which is F cos beta over here. So here it will be F cos beta by pi r square, and cos beta can also be written as sin alpha. So in this way we can find tangential stress. Now next is ratio of longitudinal and tangential stress. So take the ratio, we have either tan beta or cot alpha as the ratio. Now is another numerical based question on this. We need to find longitudinal stress for a force having 200 Newton magnitude, alpha is 60 degree, radius is 4 centimeter. So using the expression of F cos alpha by pi r square, and after calculations we have longitudinal stress as 1.98 into 10 is to power 4 Newton per meter square. Then we need to find tangential stress on the circle. So using the concept F sin alpha by pi r square as we have derived over. So after substituting the values, we get finally as 3.4 into 10 is to power 6 Newton per meter square. Then finding ratio of the stresses, so it is about 1 upon 1.7, which is roughly equal to 0.59. Now there is another interesting question that we are being given a cylindrical surface, and in that cylindrical surface we are being given this area, and we need to find tangential stress on the circle. So here there will be stress on the surface, and if we assume that here the force F is applied, so there will be F force over here. Now this angle is theta, so we can break the force on the cross section into F cos theta and F sin theta over here. So we can say that tangential stress will be taking component of force along the plane. So that will be F cos theta by A, and area here will be pi r dash square. I take this radius as r dash. So now r dash can be written as r by sin theta. So after calculations, tangential stress will be given by this expression. Then finding longitudinal stress on the circle. So for longitudinal stress, we take the uh, stress perpendicular to this plane. So that will be F sin theta by A. A here will be pi r dash square, and after calculations, longitudinal stress will be F sine cube theta by pi r square. Then we need to find the ratio. So ratio will be here cot theta. Then we have another discussion on cuboid based problem. A cuboid is given over here, for which Young's modulus is 2 into 10 is to power 9 Newton per meter square. And on the cuboid, on the top surface, you apply a force at 37 degree. So the first question is longitudinal stress on the face EFGH. So longitudinal stress is perpendicular force by area. Perpendicular force here will be F sine 37, area will be LB. So after calculations, it comes out to be F upon LB into 3 by 5. Then is shear stress on the face EFGH. So for finding shear stress, you have to take the component of force in the plane. That will be F cos theta. So cos 37 is 4 by 5. So that will be 4F by 5BL. In the next question, you need to calculate ratio of longitudinal and shear stress on the face. So if we take the ratio, it comes out to be 3 by 4 over here. Then is find longitudinal stress if here force L and B are given. So using the concept, we can write it as 3F, 3 by 5 F upon LB. So that will be 3 by 5, force is 200, LB will be 8 meter square. So after calculations, it comes out to be 120 by 8 Newton per meter square, or 15 Newton per meter square. Then is finding shear stress for question 4. So shear stress we have calculated as 4 by 5 F by BL. So 4 by 5, F is 200, BL is 4 into 2. So that will be 20 Newton per meter square. Then is finding ratio of longitudinal and shear stress. So we take the ratio will be 3 by 4. Next is dimension of longitudinal stress. So that will be M1 L minus 1 T minus 2. It's same for shear stress as well as for the ratio of longitudinal stress to the shear stress. The dimension of this quantity will be dimensionless, as both have the same dimensions. Then we have a prism, this wedge based problem. A wedge is given to you, and force is applied as shown in the figure. We need to find longitudinal stress on the face ABCD. So if we decompose this, so the perpendicular force comes out to be F sine theta, and area we take at A. So for calculating area, this side is L and this side will be root under B square plus L square. So area will be root L square plus B square into L. So from here, this will be the longitudinal stress on the wire. The next question is finding shear stress for ABCD. So for shear stress, we have to take F cos theta divided by the area. So that will give us shear stress. Next is find ratio of longitudinal and shear stress. So if we take ratio of these terms, the ratio will be sin theta by cos theta or tan theta. Then we have another discussion on numerical problem based on stress and strain. So a rod of iron has length 4 meter, area of cross section is 20 mm square, and Young's modulus is given to be 2 into 10 is to power 9 Newton per meter square. Then we need to find, the first question is volume of rod. So volume is pi r square L. So from here, if we calculate, that will be area of cross section here is 20 mm square. So that will be 20 mm is 10 is to power minus 3 meter whole square, and length is 4. So volume will be area into length, and from here, if we calculate, it comes out to be 8 into 10 is to power minus 5 meter cube. Then is longitudinal stress for force. So longitudinal stress is force by area. After calculation, it comes out to be 20 into 10 is to power 6 Newton per meter square. Then is longitudinal strain for this force. So strain is stress by y. Stress is 20 into 10 is to power 6. Y is given over here. So from here, if we calculate, it comes out to be 1 by 100 or 0.01. Then is elastic potential energy density. It is half into stress into strain. So stress is this, strain is this. So after calculations, it comes out to be 10 is to power 5 joule per meter cube. Then is elastic potential energy. So it is elastic potential energy density into volume. After calculations, it comes out to be 8 joule. Then is next question, if length is doubled, then new Young's modulus of the rod. So Young's modulus is independent of the length. It just depends on nature of the material. So it will remain the same. Next is if length is halved. Then new Young's modulus of the rod, so it is independent of that, so Young's modulus will remain the same. Next is if area is double, no effect, same. Next is both area, it will remain same. Half, if we do vary things so that they becomes half, it will be the same here. Then does breaking stress depends on area? No, it is independent of area, but dependent only on the nature of material. Next is, does breaking strength depends on area? Yes, it is in fact proportional to the area. Then we have next discussion on dimension of elastic potential energy. So it is m1 l minus 1. Sorry, for energy is there, so L2 T minus 2. The next is dimension of elastic potential energy density. So it is energy by volume. So the dimensions are m1 l minus 1 T minus 2. Then we have dimension of Young's modulus. It is again same, m1 l minus 1 T minus 2. For bulk modulus, it is also same. For shear modulus, it is also the same. Then we have another discussion on match the column type. So here are certain physical quantities. Here are the dimension. Let's match them out. So first of all, stress has got dimension m1 l minus 1 T minus 2. So stress matches with B. Then energy has got dimensions ml2 T minus 2. So it matches with the option F. Then strain is dimensionless. So it matches with the option E. Then energy density has dimension m1 l minus 1 T minus 2. So it matches with the option B. Area has dimension m0 l2 t0, so it matches with G. Volume with L cube, so it matches with L. Then we have concept of magnetic flux. So magnetic flux has the dimension this ml2 t minus 2 I minus 2. Then self inductance. So self inductance is this is for self inductance. And magnetic flux has got this one I minus 1 will be there in magnetic flux. So magnetic flux corresponds to D. And self inductance here, self inductance, yeah, it corresponds to point C. Then force is very simple, m1 l1 T minus 2 is matches with A. Now there is another match the column for finding relating to the units. So Newton is unit for force, so it matches with the m1 l1 T minus 2. Newton meter corresponds to work or torque, has dimension ml2 T minus 2, corresponds to the option D. Joule per meter cube corresponds to energy density m1 l minus 1 T minus 2, so it corresponds to the option E. Henry is for self inductance, so it is ml2 T minus 2 I minus 2, corresponds to the option H. Then Weber is unit for magnetic flux, so it corresponds to the option G. Then Newton per meter corresponds to the option I, as length component will be 0 over here. Then meter square L2, so it corresponds to option A. Then meter cube corresponds to B, and volt corresponds to F, ml2 T minus 3 I minus 1. Then is another discussion on fill in the blanks type questions. So stress is magnitude of force by area, strain is change in parameter by original parameter, stress 3 types, strain 3 types, modulus of elasticity 3 types. Young's modulus is ratio of longitudinal stress and strain. Bulk modulus is ratio of volumetric stress and strain. Shear modulus is ratio of shear stress and strain, and dimension of Young's modulus is m1 l minus 1 T minus 2. Then is another worksheet on stress and strain. So stress is a basically scalar quantity can be used, but more generally it's a tensor quantity. If we deal with higher dimension, it's basically a two-dimensional tensor, but it is added in the same way as a scalar quantity is added, because there is no angle component involved in that. But if we observe in 3D dimension, it's a tensor quantity. So more better word would be tensor. So it's a tensor quantity. Next is strain is the ratio of change in parameter by original parameter. SI unit is Newton per meter square. CGS Dan per centimeter square. Ratio of SI CGS unit of stress is 10. SI unit of strain is unitless because it is dimensionless also. CGS unit is also unitless. Then dimension of stress is m1 l minus 1 T minus 2. Dimension of strain m0 l0 T0. Stress by strain m1 l minus 1 T minus 2. Young's modulus m1 l minus 1 T minus 2. Bulk modulus m1 l minus 1 T minus 2. Modulus of rigidity m1 l minus 1 T minus 2. Dimension of stress square by it will be the same. Dimension of stress and strain same as m1 l minus 1 T minus 2. Then dimension of y into strain square This is energy density, has the dimensions m1 l minus 1 t minus 2. Then stress square by y square. So stress and y have same dimension. So that will be m0 l0 t0. Dimension of energy m1 l2 t minus 2. Dimension of work m1 l2 t minus 2. Dimension of energy work m0 l0 t0, as both are dimensionless. Dimension of energy density m1 l minus 1 t minus 2. Potential energy ml2 t minus 2. Kinetic energy m1 l2 t minus 2. Then we have another worksheet on dimension of stress. It is m1 l minus 1 t minus 2. Dimension of strain m0 l0 t0. Dimension of modulus of elasticity m1 l minus 1 t minus 2. Dimension of Young's modulus m1 l minus 1 t minus 2. Dimension of modulus of rigidity m1 l minus 1 t minus 2. Dimension of bulk modulus m1 l minus 1 t minus 2. Dimension of shear modulus m1 l minus 1 t minus 2. Energy density m1 l minus 1 t minus 2. Elastic potential energy m1 l2 t minus 2. Then we have to write SI unit of the following. For stress, the SI unit is Newton per meter square. Strain is unitless. Modulus of elasticity Newton per meter square. Young's modulus Newton per meter square. Bulk modulus Newton per meter square. Modulus of rigidity Newton per meter square. Hydraulic stress Newton per meter square. Volumetric stress again Newton per meter square. And hydraulic strain, it is again unitless. Then is another worksheet on elastic potential energy. So it's half into stress into strain into volume. Then if we analyze U by V corresponds to energy density. So it's graphical variation with stress for constant Young's modulus. So expression used is stress square by 2y. Graph will be parabola. If we draw the graph between energy density and Young's modulus at a constant stress, so that will be rectangular hyperbola. However, if we draw graph between energy density and you can see the strain for constant Young's modulus, that will be a parabola. If you draw the graph between Young's modulus and y Young's modulus, that will be again a straight line. Now there is a question based on nylon rope. So nylon rope has radius r, area of cross section capital A, breaking stress B, then find breaking strength. So breaking strength is breaking stress into area, so that will be B into pi r square or B into A. Next is how breaking strength depends on cross section area, so it is proportional to area for a given breaking stress or material. Next is how breaking strength depends on radius of cross section, so it is proportional to r square for a given breaking stress, so the graph will be a parabola over here. Next is, does breaking stress depends on area of cross section? No. Breaking stress depends only on the material. Next is, does breaking stress depends on the radius of cross section? No, because it depends on the material. Next is breaking stress same for ropes of same material? Yes, because breaking stress depends on the nature of material of the rope or rod. Next is, what is the ratio of the breaking stress of two ropes of nylon having radius r1 r2? So material is same, so breaking stress will be same, the ratio will be 1. Next is, what is the ratio of the breaking strength of the two? So breaking strength will be proportional to area for same material, so the ratio will be a1 by a2 or r1 square by r2 square. Next is dimension of breaking stress, so that is m1 l minus 1 t minus 2. For breaking strength, it is m1 l1 t minus 2. Now sagging produced in a beam, this is also called deflection in beam or deviation in beam or bending of beam. So it is WL cube by 4 YBD cube. Then dimension of bulk modulus is m1 l minus 1 t minus 2. Then we have another discussion point on Young's modulus dimension. So it is m1 l minus 1 t minus 2. SI unit of Young's modulus, it is Newton per meter square. CGS unit Dyne per centimeter square. Young's modulus depends on nature of material. Now a wire is given to us having area of cross section capital A elongated by delta L, applying a tensile force F. Then Young's modulus is, so Young's modulus is stress by strain. Stress is force by area, strain is delta by L. If we combine the form, we get Young's modulus as FL by A delta L. Then what is equivalent spring constant of a rod in terms of its Young's modulus? So equivalent spring constant is AY by L. Then is dimension of shear modulus, it is m1 l minus 1 t minus 2. Then is SI unit of shear modulus, it is Newton per meter square. Then is CGS unit of shear modulus, it is Dyne per centimeter square. Then shear modulus is also called, so this is also called modulus of rigidity. Next is for most of the materials, ratio of shear modulus and Young's modulus. So for most of the material, the ratio is 1 by 3. Next is dimension of bulk modulus. So it is m1 L minus 1 T minus 2. Next is SI unit of bulk modulus. It is Newton per meter square. Next is CGS unit of bulk modulus. It is Dian per centimeter square. Next is ratio of SI and CGS unit of bulk modulus. It is 10. Next is reciprocal of the bulk modulus is called. It is called compressibility. Next is dimension of compressibility. So it is inverse of that of bulk modulus. So bulk modulus has m1 L minus 1 T minus 2. So it will be m minus 1 L1 T2. Then is SI unit of compressibility. So it is inverse of that of bulk modulus. So meter square by Newton. Then we have another discussion on stress strain curve for a particular material. So here the first question is proportional limit. So the point up to which graph is a straight line is called the proportional limit. So it corresponds to point A. Then is yield point. So yield point is given by point B. Then is elastic limit. So it is also called the elastic limit B. Yield strength. So yield strength is corresponded by the stress for point B, which is sigma B. Then is after what point strain is non-zero while stress may be zero. So it is after point B. Because yes, strain is non-zero, that corresponds to permanent deformation or permanent set. Then is which point corresponds to ultimate tensile strength. So here D corresponds to the ultimate or the maximum strength as it is given in the graph itself. Then which point corresponds to fracture point. So fracture point is given by point E. Next, when is a material called brittle? So material is brittle when the gap is a small separation between ultimate stress and the fracture point. Now is when is a material called ductile? So material is ductile when the gap is large or X is large. Next is stress strain curve for elastic tissue of aorta. So that will be a curved graph as per given in NCERT. Then is does elastic tissue of aorta follows Hooke's law? No, it's a non-linear graph and it does not follow Hooke's law. Next is substance like tissue of aorta and rubber. So they are called elastomers. Next is ratio of stress and strain. This is called modulus of elasticity. Then is ratio of tensile stress and longitudinal strain is called, this is the Young's modulus, because both are the same thing. Longitudinal stress can be tensile as well as compressive, so it's the Young's modulus. Then ratio of compressive stress and longitudinal strain is again Young's modulus. Then we have another worksheet on Hooke's law. So according to Hooke's law, stress is proportional to strain up to proportional limit. Graph between strain that will be straight line till elastic limit. Modulus of elasticity, slope of this graph, which can be tan alpha or cot beta. Then here 3 points are given. So elasticity modulus is the slope. So we can say it is positive where slope is positive, which corresponds to point C. It is negative where slope is negative, which corresponds to point A. And it is 0 where slope is 0, it corresponds to point B. Next is find elasticity modulus. So here angle is 60. So elasticity will be 1060 or root 3, which is 1.732. Next is in this question angle is taken from the strain axis. So it will be 1030 or 1 by root 3. Next question is find dimension of stress. So it is m1 L minus 1 T minus 2. Dimension is strain m0 L0 T0. Dimension Young's modulus m1 L minus 1 T minus 2. Dimension of stress square by Young's modulus. So that will be having a dimension equal to stress, which is m1 L minus 1 T minus 2. Next is dimension stress into strain, that will be m1 L minus 1 T minus 2. Dimension of Young's modulus strain square. Strain is dimensionless, so this dimension will be m1 L minus 1 T minus 2. SI unit of stress Newton per meter square. SI unit of strain is unitless. SI unit of modulus of elasticity, that is Newton per meter square. Then is another worksheet on stress and strain. So we are being given a cylindrical rod and a force of F is applied on the rod as shown in the figure. Length of the cylinder is L, radius is R. So the first question is longitudinal stresses. So this is force by area, so that will be F upon pi R square. Then is longitudinal strain, so this is delta L by L. Now is a numerical problem on this. Force is given, radius is given, so stress is force by pi R square. If you calculate using this expression, it comes out to be about 4 into 10 is to power 8 Newton per meter square. Then is calculation of longitudinal strain, so this is stress by Y. If we calculate, it comes out to be 2. Then is concept of elastic potential energy density in the wire, so that is half into stress into strain. If you calculate, it comes out to be 4 into 10 is to power 8 Newton per meter cube or joule per meter cube. Then is find elastic potential energy stored in wire for length is 4 meter. So elastic potential energy will be density into volume. So after calculations, it comes out to be 803.8 joule. Now there is a question in which a force is applied on a rectangular surface at an angle of 60 degree with the plane. So the first question is find longitudinal stress. So it is perpendicular force by area. Force perpendicular will be 100 sin 60, area is 24. So it comes out to be 3.46 Newton per meter square. Then is shear stress. So shear stress will be parallel force by area. Parallel force will be 100 cos 60 by 24. So it's about 2 Newton per meter square. Then ratio of longitudinal and shear stress, it is 1.73. Then there is algebraic problem on that. Force is given in algebraic form F theta. So here is the question is cross section area. So it's a rectangle, so cross section area will be LB. Longitudinal stress perpendicular force by area. So perpendicular force will be F sin theta, area is LB. Shear stress is parallel force by area, F cos theta by LB. Ratio of stress tan theta. Now there is a question based on that. So the first question is stress is, so it's a tensor quantity. Strain is a scalar quantity. SI unit of stress Newton per meter square. SI unit of strain is unitless. SI unit of Young's modulus Newton per meter square. SI unit of bulk modulus, it is also Newton per meter square. Then is another worksheet on stress and strain. So the first question is dimension of stress. It is M1 L minus 1 T minus 2. Then dimension of strain M0 L0 T0. Then dimension of stress by strain. It is M1 L minus 1 T minus 2. Dimensions of Young's modulus. Same M1 L minus 1 T minus 2. Dimension of bulk modulus M1 L minus 1 T minus 2. Dimension of modulus of rigidity M1 L minus 1 T minus 2. SI unit of stress Newton per meter square. CGS unit of stress Dan per centimeter square. Next question is how many types of stress are there? 3 types. How many types of strain? 3 types. How many types of elasticity modulus? 3 types. Longitudinal stress is magnitude of perpendicular force by area. Shear stress magnitude of parallel force by area. Volumetric stress by hydraulic stress, both are same, so it will be 1. Next is which is more elastic out of steel and rubber? So steel is more elastic because it is more rigid. Now is ratio of stress and strain. So this is called modulus of elasticity. Then Young's modulus is longitudinal stress by longitudinal strain. Bulk modulus here is volumetric stress by volumetric strain. Shear modulus is tangential stress by tangential strain. Elastic potential energy is half into stress into strain into volume. Then it's another point related to the mechanical properties of solid. First is introduction. So second is the content here is introduction, stress strain curve, elasticity modulus, elastic potential energy and application, and this is the stress strain curve for that substance. So here is another discussion on stress strain curve, as I have already discussed. Some question based on calculation of work done by the force. After integration, it comes out to be this much, which is half into stress into strain into volume. So work done by the force. Then is a question based on series and parallel combination of resistances. Again, stress strain curve bending in a beam. Then is again a question based on mechanical properties of solids, comprising of introduction, stress strain curve, elasticity modulus, elastic potential energy and application. The graph shown over here, various points related to that, and stress strain curve. Then is another qualitative discussion on belief system versus knowing systems. Knowing means you are not dependent even on your mind brain system, even on the information which is embedded in you right from the moment you were born. So human consciousness is continuously searching for the knowing things, to know what exists. Memories, experiences, beliefs just try to trap consciousness, but life is a continuous process, and consciousness can't be trapped by any mechanism. So here is another problem related to component of forces, various cases, NCRT, DPPs, IV analysis in resonance and AC circuits. Yes, it is another discussion on some complex circuits involving resistance, symmetry based circuits. Then is a qualitative question on equation of a circle, which is given by the expression calculation of the diameter. So these are some points related to what I have worked, my hobbies. Then there are certain questions on variation of electric field due to ring, which is maximum at r by root 2. Then certain questions based on them. Then are certain questions, certain things based on what I have done. Now there is a education psychology based video that why preparing for competitive exam is so much challenging. So because it uses high frequency brain waves, for that let's discuss one of the question that suppose I give you that 2 raised to power x is sin x, find values of x. So if you analyze this question, it requires high brainwave frequencies. So there is no simple explanation to this. What you need to do is draw the situation graphically. So we have sin x curve like this, and we have 2 raised to power x curve like this. So as you can see from the left hand, there are infinite point of intersection. So there are infinite solutions, but for all of them follows x less than 0. So this is how you can calculate it out. So thing here is that the competitive exams are so difficult to crack because they involves use of high brainwave frequencies, and you have to develop being adaptive to the high frequency brainwaves by working for a long duration of time. Normally it takes about 5 years. So if you will try to change your frequencies abruptly, or you will hurry, then you will not be able to adapt to those frequencies. You will struggle with thoughts, emotions, energy, information, but will never be come up in a proper mind brain system to get answers of the question. So that is why preparation is important, because it involves use of your brain and mind as a system and in a high pressure conditions. Normally what happens is when a student starts solving a problem, there is use of multiple lobes of the brain. He need to fetch information, he need to use contemplative skills, he need to use memory, he need to use analysis, he need to use visualization. So multiple parts of the brain gets activated simultaneously, and it leads to sort of anxiety. It's like if I give you 10 tasks at the same time, that you study, you listen to music, you eat also, you make some drawing, you do this, you do that. So you won't be able to focus on a single task. And ultimately you'll be in a state of hurry, anxiety, depression, etc. So that's why competitive exams are so hard to crack. The percentage of successful students lies between about 2.8 to 3% because of the high frequency involvement. And those students who are selected, they train their mind brain system for being adaptive to the high frequencies right from class 5. So from 5 to 12 there is 8 years. of preparation. So the result that you see is because of the hard work during those 8 hours and consistent performance. That is more important. So if you want to know more, you can refer to some of videos on YouTube. So it is OST by Acharya Vishvendra or Secrets of NEET Toppers. So I have done phenomenal work on education psychology and especially physics as a subject. So you can search them and if they can stimulate you to perform better, I'll be happy to do something for that. Then is talking about the education strategies. So the concept of preparation is about three things: information, process, and energy. Energy is about negative, positive, and neutral. So if you see, positive energy means you are happy, negative means you are sad. So there is something to interact with your brain and mind system. So your brain and mind work as a system to generate something. For example, yes, here it is discussed that yes, there is a problem on area, and the concept here is that liquid is placed in a container, and the height of liquid does not change with respect to the ground. So relation between gamma will be gamma liquid is twice alpha solid. Then here are certain discussions on elasticity, types of stress, strain, elasticity modulus. Then here is mechanical properties of solids, introduction, stress, strain, application, potential energy curves. Then a discussion on moment of inertia. Then for pure rolling cases, moment of inertia for a system. Then various questions based on that. Then is some qualitative analysis, quantitative analysis, sigma bond, pi bond analysis, graphical analysis of parabola curve, straight line graph, various analysis. Then is a graph of mod x plus mod y 20. It will be a square shape graph, just like this. Yeah, there is a qualitative discussion that for solving questions of JEE Advanced Physics, you have to deal with both the belief systems and the free thinking, and you need to use them as a system, because belief systems are needed to use the laws, because you cannot make the laws. You need to use information or the equations which are already verified by the scientists, but certainly you are free to visualize the situation to use parietal lobe of the brain. So there is a coordination of both the things, belief system as well as the free thinking system, and you can coordinate them in a certain way, then certainly you can be able to crack competitive exams. Then another question based on angle between various lines. Then is another discussion on neural links, calculation of moment of inertia, free based questions, problems of the students. Then is another concept on my video channel, Project AV, concept of elasticity, different topics as given over here, stress strain curve. Then we have another video on the concept of analysis of qualitative working as given over here. The discussion involves the variation of graphical analysis and the questions based on them. So it's about the triangle, the square, the various terms, the various concepts related to that. Then is the problem related to ineffective learning method and effective learning methods as shown over here. Then graphical analysis of EMF as a function of self-inductance as shown over here. Then is a graph based question and integration based question with the limit from 0 to pi by 2. Then we have some problems based on parabola, then circle, various points related to that, beliefs versus truths. So here is the analysis of this point. Then we have a certain problem on collision between block and wedge, various questions related to video lectures, question answer session, DPPs. Yes. Then analysis of performance, and roots and law. Here is interesting thing. This is Yerkson and Rudson law. You see, it was Yerkson and Rudson were psychologists, and they performed experiments on a number of performers across a diverging range of areas. And what they found was there is a certain point at which stress is optimal. If the stress goes beyond the optimal stress, performance declines, and you feel like exhausted, lack of motivation, lack of energy. So if you want to perform optimally, you need to learn that how to be within plus minus 5% of your optimal stress level, because optimal stress level is different for all. It's different for individual. It depends on the DNA, the mind brain system, the bringing also, but mostly concerned with the DNA of a particular person. So if you want to get optimal performance, just try to learn to be within plus minus 5% of your optimal stress level. Then is another discussion on information processes energy, as I have already discussed. Then another discussion on physics by AV concept involved over here. Then another discussion on certain points related to topics of physics, just like time period of a simple pendulum calculations based questions. Then project AV, mathematical questions on that. Then a problem based on calculation of a spring mass system, their analysis. Then there are certain questions based on elasticity, live class discussion, a problem based on integration and probability. Then there is mechanical property of solid analysis, graphical analysis, questions based on that. Then is project V, services provided, a snapshot of the expression of friction in case of rolling on inclined plane. Talk less, do more, and no disturbance should be, on you. Then is social awareness program. Then is project AB, which started by me, number of pages, my official email ID, frequency variations. Then it's the concept of elasticity, project V, information process energy combination, problem based on pure rolling on horizontal surface, concept of self-inductance. Then analysis of the chapters, some problems based on triangle. Then we have elasticity, and important discussion for students that मन क्यों नहीं लगता किसी काम में. So it's all about your frequencies. Then is quality oriented working, project AV, concept of NCRT DPP class note, NEET PYQs, stress and strain, tensile and compressive, tensile or shear, volumetric, various questions based on them. Then is a time period of a simple pendulum. Then is another discussion on elasticity, various points, concept of self-inductance, concept of current in a circuit, various cases related to moment of inertia. And at the last we have concept of elasticity, various cases, communication skills, or mechanical properties of solids. So this was one of the video on the to show you what work I have done. Soon I shall be making videos, elaborative videos, in which I'll be explaining things in a more elaborative way. So if you have any doubt, you can ask in the comment section. Thank you and have a nice day.